Okay, so Kirchhoff's law. Why do we use Kirchhoff's law? Whenever you have a circuit or we have the branch of a circuit and we want to find unknown current or the unknown voltage across the resistance within a circuit or the branch of the circuit, then we can use Kirchhoff's law. First thing. Second one, what is Kirchhoff's law and how do we use this? This is the most important thing that we should know. First of all, the Kirchhoff's law is applied to a closed loop. So I'll just draw an example of the circuit where, for suppose this is R, one resistance R1, another you think this is as the R2 resistance, and here I am taking one battery like this, and then it is R3 here, then I put again one more battery here, and from here to here again I will put one more resistance, then one battery I will put here like this. So if I name it A, B, C, D, E and F. As we see, this is a very simple circuit. Like we can see a rectangle. One rectangle A, B, C, F. Another one F, C, D, E. And another one also we can see A, E, D, B. So Kirchhoff's law is applied across a closed loop. First thing. So you can choose the loop according to your own desire and convenience. And for suppose here, if we want to find the current in each branch or the voltage across each resistance, then we can choose to use Kirchhoff's law. So we'll use that one. But before that, what is Kirchhoff's law? It consists of two laws. What are those laws? Kirchhoff's laws. The first we call Junction rule. Since the charges are conserved, that is, for suppose 5 ampere current passes from here and we get a point here, from here two branches get out. So for suppose 3 ampere current goes into this direction, so the 2 ampere current will go into this direction. So 3 ampere goes towards C and 2 ampere will go towards B. So the total current in at the junction is your 5 ampere, and 3 ampere currents towards C and 2 ampere currents towards B. So the total makes again the 5 ampere out current. So the current in is equal to current out. Why is that? Because the charges are conserved, and the charges are conserved refers to that there can not be any accumulation of charge at the junction. So per unit second, whatever the charges enters through this yellow mark, that is X, whatever the charge enters here must exit into that second through that junction or through that yellow point. That is the main thing which is followed by the junction rule. So it is based on conservation of charge principle. Okay, we can also say that it also suggests the additive nature of the current, that whenever it enters through the junctions, so that this current is equal to sum of these two current. So we can write it like this one, that current in is equal to current through C plus current through B. Current through B. These two sum gives you the total value of the current which enters into it. Also one more thing, whenever you use junction rule or the law, you can get the current value to be negative as well. That doesn't mean that you are wrong or the charge is negative. No, it does simply tell you that if you have taken the current direction to be in this direction and you get minus 5 ampere, so this minus 5 ampere only suggests you that you have taken the arrow in this direction, but it is opposite of the one you have assumed. This is what it is. So when you get the current value to be negative, don't worry. It just tells you whatever you have assumed the direction, it is exactly opposite of that. So within a loop, for example, you can suppose any loop. You can take instance of any loop and you can apply this junction rule or whatever this voltage rule I am going to say right now. So first of all, consider a loop. So for my convenience and for you as well, I am going to take one simple loop, that is A, F, C and B. So consider consider A and A, F, C, D. I take this loop. So within this loop, you have to plot the current first. So I'll mark the current as well. So see, the battery is in this direction. From here to here, this is positive terminal and this is your negative terminal. As per the assumptions or as per the sign of the battery, the big stick refers to the positive side, the high potential, and the smaller one refers to the negative potential, that is the lower potential. So put positive sign here and negative sign here. Now assume, or I assume, that the current goes in this direction. So here I assume to be the current equals to I. So take this current to be equal to I. So same amount of current will enter here, that will be plus. The current moves from or flows from high potential to low potential. So across the resistance, what you do, put the sign positive at the end where the current enters and negative where the current makes exit. So this is positive, this is negative. So you make a sign of that one, the flow of the current. According to that, you put positive here and negative here. Then again the positive here and negative here. So now the current comes over here at this point. So whatever the value of the current has gone here, according to the junction rule, what will happen? It will divide. You don't know how. So we don't have any numerical value here. So I'm just telling you, showing you how this junction rule applies. This current I comes over here. I does not bother that how you have taken the direction of the magnitude of the current, but ultimately you have taken here I. So this I comes over here, and this I is not the total current which is in the circuit or the total current or the sum of the total current in the circuit. It just simply tells you the value of the current where what is in this branch. That's it. So I will make a division like here it will go. I'll take another color to show it more clearly. So here it goes suppose I1 and here it goes suppose I2. Make the color more light so you can understand it. This is I1 and this is your I2. The same I2 current, here it will be plus and here it will be minus, so will flow through this one. And now again there comes one more junction at this point. So some current will go here and some current will go in that direction. In this direction you will have only I. Why? Because in the same branch you cannot have two different currents. So the I will enter from here, then only this I will make the exit. That is why from I2 current here, I current goes here. So what the current goes in this direction, that will be according to the junction rule I2 minus I. I2 minus I2 is coming total current at this point and I1 goes here. So whatever the left current is, that is I2 minus I will go into this direction. That's it. So as per the junction rule, we have taken the loop AFCB and we have plotted positive, negative across the battery and the resistance as well, and we have taken the current as well. So it's very simple. You assume or you consider a loop across the battery, put the bigger stick as the positive and the smaller stick as the negative, and the high potential and the low potential. Then assume the direction of the flow of the current, and according to your assumption of flow of the current, put across the load, that is the resistance or the bulb or the fan, whatever we indicated in the branch, the point where the current enters, mark that as positive, and the current where it makes the exit, the end where the current makes the exit, mark that as negative one. Okay, so this one on the basis of the junction rule, I marked it everything. Okay, now there is another rule of the Kirchhoff's law, the Kirchhoff's rule, that is voltage rule. What happens in the voltage rule? Voltage is basically the potential difference. Potential difference between 2 points is called as a shorter name voltage. So for suppose if someone starts from here and returns to the same path, so the net displacement is 0. The total work done by that charge or by that body is 0 because the displacement is 0. On the basis of this one, this principle, the voltage rule depends. It is based on the law of conservation of energy. And also, since electric potential or the electric force is a conservative force, so when some charge returns to its initial point or there is no path position difference between the charges, initial point and the final point. So the total work done would be 0. So that means the sum of the total potential difference must be equal to 0. On the basis of that, this voltage law acts. So within the same loop, so we'll write first sum of the total voltage, sum of total. You may find different versions of this statement. I would say that don't write this statement. What I am writing here, I am just writing here to make you understand. But when you want to write a perfect answer when asked in exam, please refer to some standard textbook, or I preferably suggest you to write this from the NCERT book, the two Junction rule and the voltage rule. Take the proper statement from there and write it. So sum of the total voltage along a closed loop is equals to 0. That is it, 0. How do you get this and how will you measure this voltage? Okay, so I have a very simple theory for that. You have already considered this loop. Here it is the loop. Okay, now what you have to do, you consider any point along that loop. So for suppose I will just change the color and we'll take this one. I think this is good. For suppose I start from here at this point. Maybe it's visible. Okay, from this point I start from this point. You are free to walk along the loop, the first loop. Without hesitation, you can walk along the loop. It's your wish or desire that how you want to walk. You can either walk in this direction or walk in this direction. If you want to walk from half of the resistance, that also you can do. You can start from here in this direction, but following the loop, the closed path, you return exactly at the same point where you have started. So the thing is, you can start from any point and start walking in the loop and then come to the same point. This is the main principle when you apply this voltage rule. Now what you have to do, so the simple theory is that when you walk and you meet positive and negative sign, so when you encounter positive to negative, that you walk from positive to negative, for me it just simply shows a kind of decrement. So collect the voltage. How will you collect the voltage? When it is battery, so the voltage is already given with the battery. Good. But when it is load, the resistance, fan, light or anything, how do you get the voltage? So the voltage given by V is equal to I into R. Whatever the current you have assumed or you have placed in the first by using the junction rule, you multiply with the resistance and you will get the voltage. And before that voltage, according to the sign, you put sign, that is here the sign positive to negative when you move. So for my convenience, I suggest it to be understand as decrement. So the sign of the voltage you have to take as negative. If you want positive, you can keep them. No worries for that. You will get the same answer. But for my convenience, when it is positive to negative, that means I am degrading myself. So I'll take the voltage to be negative. Okay. After that, when you go from negative to positive, so that sign is a good sign for me. That shows some increment, that I'm upgrading myself. So I keep the voltage to be positive. And you add them all total and place equal to 0. You can take reverse one as well. That is positive to negative, you can take positive, and negative to positive, you can take negative. That's it, as you wish. Okay. So let's start doing this one. So here, for suppose I take the voltage, the first one, let me mark some name. So here, for suppose it is E1. Okay. This resistance to be say for suppose R1, R2, R3 I have taken already. So let it be R4. Okay. So I start from here and I want to walk. Deliberately I am walking in this direction because you guys have misconception that you have to walk along the direction of the current. That's not the truth. You can walk in any direction. That is, that's why I will walk in this direction. So I will follow this path. So at first I get positive to negative. So the sign is decrement. And I'll get the voltage to be minus E1. Due to plus to minus, it is minus E1. So minus E1. That is it. Now I'll come here. So no resistance. So no load, no voltage. Then I go here it is negative sign, it is negative, and then it is positive. So I am transiting from negative to positive, so it is the increment sign. The current here in this branch is I2 and resistance is R2. So minus to plus, so it's plus, and the voltage, what is this voltage? Current into resistance, I2 into R2. So it will be, I'll write plus I2 R2, that is good. And then I come here, from again I have to go in this direction because I have to return to this point. So minus to plus, it is again minus to plus, so plus I R1, so plus I R1. Do not get confused, I'm going from negative to positive, so increment and then I into R1, that is the voltage of this thing. So plus I R1, and from again here to it's minus to positive plus, so again positive I R4, positive I R4, and I return here, no voltage there, so that is equal to 0. So this is my one expression for the one loop. So this is how I get one equation. So I'll put lot of the values, the different values for that one. Again for this one I'll get another equation, and for if I consider this whole loop, I'll get another equation. See, I have assumed the current here, I'll just enlarge it so you can have a good look on it. Okay, so here it is I. So I have already taken I. So now you don't need to worry about other branches of current. Here you already had as I1. This is I1. So it is minus, this is plus. I'll mark it with different colors so you understand it. This is minus, this is plus, and so how it goes in like this. Okay, so this is minus, this is plus. So already have the branches of the current and all. Okay, so you see, do two currents contradict itself, right? So the one current must come negative. When you solve the equation, you will get it. This is a good question. I'll put some values here. For suppose you take this as E2 and you take this as E3. Maybe it's good, E3. And then we can have another equation. And from there we can solve it and we can find for any unknown variables when we have the known quantities are given into that. So I think this is a good thing that you have understood this Kirchhoff's law, and you can apply this to any kind of the loop. And sometimes we get Wheatstone breeze related to that. I'm not solving it because I just took the example, so a lot of the data you can put here and you can solve it. Just I showed you how you have to use the Kirchhoff's law, the Junction law, the voltage law, on what basis they are based on. So when you get the numerical, try with the good questions where the numerical values are there, some previous year questions or from textbook questions. You try the loop and try to solve this to get some real answers, and where you can match the details of the answers. Okay, and in NCERT you can find a lot of the reference questions related to the Wheatstone breeze, where you have this kind of the figure, but the Wheatstone breeze are not balanced. Normally what happens that these two products equals to these two products, and then we get this as the balanced one because here no currents are there. But in NCERT there are 2 to 3 questions in the exercise. The previous NCERT is like prior to 2022 and maybe prior to 2022, and after that there are only 2 questions, I think, the exercise and the examples as well. So where this Wheatstone breeze are not balanced, so here you may consider different loops like this. I'll draw this as fast as I can, so no need to worry. So here it may move like this. Another, I have just taken a reference direction, so you can have 2 loops, one and the second one. If for suppose the battery is connected, so the another loop is also there that you can take this as a loop. Okay, so you can have the 3 loop. Mark my pen movement. See, one loop I am taking in this direction and another loop this one, another loop this one. So the 3 loops are there. So write the equations. So you are able to solve Kirchhoff's law questions when you are good at the equations. So the linear equations should come. The special tips is that when you get multiple loops, try to make the equations or the number of linear equations equal to the number of variables. Then only you would be able to solve it perfectly. So thank you for watching, and follow for the next video. Thank you.